Hello, good morning. Although it is good afternoon right now. Hello, is it okay that if you guys are comfortable, you can turn on the cameras also? Would like to meet everyone at least today. Hello, let everyone joins. So what's happening? What's happening? Mithun is here. I guess your name shows as Kasar. What should I call you?
Yeah, coffee, coffee. Yeah.
Kasar. Okay, Kasar. Okay, so you both both of them, like one is in Norway, one is in London
Oh,
from
is
Europe.
it? I didn't know about Kausar
Yeah,
that he is in
I think
London.
he's, yeah.
Yeah, I'm still yeah, I recently just relocated from Poland to London, so I'm still like in an Airbnb.
Oh, nice.
But good that he still decided to take this course even in transition. So that shows his
Mm.
commitment.
Yeah, I mean, everyone who has taken shows their commitment. But anyway, like you guys have been more like active on this course, right? Even on Discord, and you have been joining all the classes right from the beginning till the end. So, mm,
Uh, uh, well, I missed couple of classes, and also on the homework side, I was not very regular as well because I was slightly involved with some other things. Like I'm getting close to getting a PR, so I have to learn Norwegian and I have to put some hours there also. So
oh,
yeah.
so how hard is learning Norwegian
Uh, means comparatively it's easy, I think. Uh,
compared to?
Yeah,
compared
it's I
to
can say that it's not as hard as learning Polish.
Okay.
possibly
But
yes.
are you planning to settle there forever, like Mithun?
No, I don't have any such plans as of now. But
Oh,
I need this PR so that because my son also then he can continue his education here.
okay.
And education here is free of charge till university. So now that
Oh,
I've paid
nice.
taxes, so I would
Mm.
like to take advantage of that.
And how much is the taxes there?
It's 40%, sometimes even more,
Oh,
42% like that. Yeah.
so straight 40% deduction, or how is it? Or is it in layers?
Uh, no,
Like
it's
in,
like for my bracket, I am paying, I think, 45%.
oh,
So, yeah.
great.
But it will come back like once
Mm,
as when you retire also they give. So there are a lot of good benefits, but you have to stay here.
mm,
So that's the catch.
mm. Yeah. What about others? Come on, guys. At least talk today. Today is the last class. I mean, for me, this was very good cohort that we did, and every good thing has to come to an end. But this is just the end of the live classes. Anyway, we'll be connected on Discord. Whenever you ping, I'll be there,
I think
right?
Rama also was doing. I think that she was interacting with me, and she's done quite some project work.
Yeah, yeah. Oh, she
Hi
was
Amit,
doing
hi
some.
everybody.
Hi, Rama.
Amit, Amit, actually there was some saturation in my work actually with just microservices and distributed systems. But with this advanced networking and C++ courses, like I got like new passion and new dreams.
Nice,
So I'm like really fascinated by this Linux and the networking and the socket programming.
nice. Even I got
Actually,
fascinated like this only. So I am very much fascinated by this networking thing,
Great. Actually, thanks for bringing this course. And wherever we search, we cannot kind of like have a consolidated list of all the important essential things for building scalable networking applications. Wherever we go, we cannot get such things.
Yeah, you can get the basics one, like how to write simple TCP socket, but I have not seen anywhere like they teach you right from the scratch, from the beginning till going to the advanced level and all.
Yes, especially
So,
the build tools
mm,
and then portable
mm,
across different platforms. That is really
yes,
rare.
yeah.
And I would say this is much like a Coursera course. And me and Mithun would always discuss. For the last 1 year, we are all like enrolled in a master's course in some university.
Oh, nice.
I mean, every content, every course from Educourses is like really very, very awesome. Both Kirti and yourself and the community, we are just like really gifted, and we really feel like it is much like in a university, and we are doing a master's.
Oh, that's
Yeah,
good
so
compliment. Great.
yeah, so I was telling to also one of your that if there is something like a fan club, then you should nominate us. Educosis fan club.
Yeah, I mean, we know about you guys more. Like Mithun, I already know from before, also from other courses. Yeah, Rama also, I think I already knew. So yeah, there are few people we already have interacted in other courses also.
So keep
Okay.
continuing and keep bringing a
Mm.
lot of such interesting things to the community, Amit.
Yeah, yeah. Thank you, Rama.
Right.
Thank you.
Okay, I think most people who would have to join would have joined. So, what shall we start our technical discussions first? Let's do away with all the topics that we have to do, and then we'll talk some more, right? Fine. Okay. So I'll share my screen. So there is one last topic that I needed to discuss. Uh, that was about IO Uring. So that was not in my initial plan that I will discuss about this, but I think this makes sense to discuss. Like whatever we have finished till now, this makes sense that we finish also look into what IO Urings brings to the table, right? And this is little bit modern concept like EPOL and all everything. If you see, that is pretty old. Like they have been there from like 20-25 years. But this IO Uring system calls are little new in the Linux system, right? So we will finish this off. By looking into the IO Uring, how it's gonna help us, how it's gonna make our code give a more throughput, less latency, right? So you can see the screen. Yeah, I think so. You will be able to
Yeah.
see the screen.
Can you
Yeah.
also cover this
Mm.
thing like if you have not already, because you in the beginning we spoke about millions of
Mm.
connections, but so is it still possible in this setting to have millions of connection by one server, or we'll have to have multiple servers for millions of connection, right? Like
See,
million is
when
one 10 lakhs. Yeah,
yeah,
so
yeah.
itna possible hai?
And means I have not seen any people have tried to go like in one company we had tried around like 4 lakhs, 5 lakhs connection parallel requests, parallel connections made. But
Okay,
then again, you have to define which system. It's not like it can be available on every system, right? You have to define how much RAM is there on that, how much CPU cores are there. So like if you have 32 GB RAM and 16 or 32 cores like that, then in those systems, yeah, it is possible. With this setup, it is possible to have
okay, okay, okay,
parallel. You are responding to parallel users, that many parallel users, right?
o- okay. But still,
So,
at the operating system level, we only have 65,000 ports, right? Operating
mm,
system level, or I don't know, switch level, CPU level, or
no, it's a operating system level. You have
okay,
65,000 ports. But yeah, for a listening port, you only need one, right?
okay, right. No, but then there will be multiple sockets created, so some ports will be utilized for that too.
So it's not like suppose 65,000 came, right? But it's not like all will be there only, right? Some people you will respond back. Those will be disconnected, right?
Okay, okay,
So you have to replenish those ports quickly. That is the point.
okay. But we cannot increase it with number of Ethernet cards
No, no. A number
because
of
it's
Ethernet cards? No, I don't think so. That is from the OS limit.
OS level only. Okay,
Yeah.
fine.
Yeah. Okay, so what we can do is we'll see how IO Uring works. So before we begin our IO Uring, first I would like to know, does everyone understands EPOL, right? We have gone through a lot of detail about the EPOL. I'll share my screen where we had done EPOL examples and all. Where is my this one? You see the screen. So if you see here in our TCP server, we used EPOL, right? Yeah. So Can anyone tell me? Can anyone tell me the working how ePol used to work? A little bit, little summary. We have done this in proper detail. Tell me.
I I think you have three. So basically, ePol is a data
Mm.
structure which is like a monitoring list,
Mhm.
and you have three major API calls for ePol. So the first thing is that um, after you have accepted a connection,
Mhm.
you will basically add this newly created socket for that connection to the monitoring list of which goes inside this ePol data structure. So you kind of
Yeah.
subscribe for the notifications, and
Mhm.
then you have another call to poll all the sockets
All
wherever
all the sockets.
uh, wherever there is data available. It will
Mhm.
return to you the number of sockets where the data
The
is
data is
available in
available.
the
Yes,
receive
yes,
buffer.
yes. So that is ePol wait we are doing.
Equal weight. Yeah.
Yeah, correct. So there are three major calls that happens in the ePol. One is first you initialize the ePol, which we were doing here. This one, ePol create. Second was whenever we have to associate some socket to the ePol. So we used to use this ePol CTL, if you remember this one, this call, right? So we are associating the my socket. Hey, I want to on this socket, if something read or write or any error comes, I am associating see these kind of events I want to listen to for this particular socket. And these are the events. And then I put it inside my associate this my with my ePol, right? So anything that comes up, any whatever the events that I've associated for that FD, anything comes up, I will get it where inside here, equal weight. So this is a blocking call. Anything, suppose in four sockets my receive happened. So this will return me four, right? Event count. And then in we'll loop through all the four and we'll check what data is, what kind of events are there, and then we'll that so suppose on one socket receive event notification has come, and then we'll go there and we'll try to do a receive, right? So if you see, we do a actual receive here. This is the receive, right? So this is how the ePol used to function. You get a notification on which FD you are ready to do send, or send has happened, or you are ready to do receive, and then you actually go and do a send and receive, right? So ePol is not doing a send and receive for you. ePol is actually just sending you a notification that okay, you are ready to do a send, or your send has already happened, or you are ready to do a receive because you have got some data on your received socket buffer, right? So this is the whole mechanism of ePol.
So
Now,
can we say that it's a observer pattern in LLD terms or a callback mechanism in C terms?
callback mechanism you can say. Basically, OS just gives you a some note kind of notification back. Okay, this is ready for send, receive, or send like that, right? Okay, so now, what is the problem with the ePol that IO Uring tries to solve, right? So still there is some problem. What is the problem? First, the problem is this is not purely async mechanism. Why I'm saying that is, if you see here, as a user, you have to handle the receive and send, right? It's just sending you a notification of receive and send. Getting my point? So as a user, you actually go and do, okay, I have to do a receive. So here, if you see, I'm doing a receive after I have gotten an event notification, correct? Or I have to do a send. So what IO Uring does is, it actually, when you say, okay, I have to do a send or receive on this particular socket, the OS takes the responsibility of doing a send and receive. You don't have to do anything. And OS will do it using its own pre-built thread pool. You don't even have to do it using your own thread pool. You can use a thread pool to do other tasks, but the receive and send is done by the OS only. It will only directly give you the result of that receive and send. Okay, you told me to do a receive on this socket. I did a receive and I have got this result. It will just give you the result back, right? This is the big difference. And how it is trying to be more faster and how it is intelligently more faster than ePOL is, there are two very big difference that makes it even more faster than ePOL. And what are the two big differences is, in, suppose if I say like this, in IO Ring, I'll show you how all calls look like. But in IO Ring, there is two major difference, which is from the ePOL, and how it helps in being more give more throughput is, first major difference is, remember in ePOL, whenever you're doing what, like whenever your notification comes, you have to do your own send and receive. And when you remember, your send and receive are all, if it is, even if it is non-blocking, it is a system call that you are making, right? Receive and send are system calls. ePOL wait is just a system call, right? ePOL CTL is a system call. And whenever any system call happens, context switch happens, and that takes time. So it makes sense if you can lessen the number of system calls, no? Your system will become little faster if you are making more system calls. So you might not see a major difference if you write some simple client and server where only some less clients are running and all. But if you are trying to plan to make it scalable for millions and millions of millions of requests per second and all, these small optimizations can help you a lot. How many, if you are making less system calls or not, right? This is one major difference: less system calls in terms of when you are using IO-Uring, and I'll show you how it is making less system calls. Second major difference that IO-Uring brings to the table is less copying, less or avoids unnecessary copying. So copying itself takes time, right? So it avoids the copying by, what it does is, so remember, when you do a receive and send, what happens is, first receive comes on the net OS layer, then it copies everything to the buffer that you have sent on the user layer. Remember, these fundas are clear, right? We have talked in great detail about this, right? So there is lot of copying that is happening from socket buffer. It comes to the OS layer. From OS, it goes to the US ka buffer, user ka buffer, and then it comes to, then we use that, right? So what it does is, intelligently, what IO-Uring does is, it creates two kind of buffers, which is actually shared between the OS layer and the user layer. So whenever any data comes, OS actually what it does is, it directly copies into the shared memory location. So there is no copying between. It is not like if first it will comes to the OS buffer, then it is copying it to the other buffer in the user layer buffer. That particular buffer is actually being shared between the user and the OS layer. So there is no less copying that is happening. Yeah, this IO-Uring, we are talking about is very specific to Linux. This is only available on Linux, not on Mac, not on Windows.
Amit, regarding the buffer, is this
Hmm.
the buffer which does the sliding window protocol?
No. This is the IO-Uring setup this buffer. When you when you initialize the IO-Uring, no, this setups this buffer which is shared between the OS and the user layer.
Yeah, but buffer means then TCP also has an internal buffer, right, where the sliding window protocol works and it keeps all the
Hmm.
data, and
Yeah,
from there it will.
that is the TCP layer is different. That is different.
Okay, okay.
Amit, one more doubt. Is it
Hmm.
something like shared memory IPC, what we usually used to have, right? That is something it does this one IOU ring internally?
IO-Uring internally is doing is, if you remember, if there is a system call that happens is, which is called, if you know, it is called mmap, memory map. So if you read
Yeah,
about
yeah.
no memory
Right,
map,
right. Correct,
it
correct.
actually,
Yes.
yeah, so it actually maps your memory, which the OS can directly use. So it is mostly used in the devices. Like suppose you have to talk to some hardware, right? So what, instead of directly talking to the hardware, directly sending the data to the hardware, the traditional way is you first tell something to the OS and then OS does the thing for you, whatever the data that has to go in the hardware and everything. But with the memory map, what you can also do is you can define a particular set of memory in your user space, and whatever the data you put in that space, it will directly be taken to the hardware or anywhere, right? So that is the main idea of memory mapping. So
Yeah, yeah, yeah. Yeah,
you
understood.
associate, you
Yeah,
assign
but
some buffer which is shared between the OS and the user layer.
yeah, Amit. Then I understood. But then very strange because even the window also supports this memory mapping, but maybe they might not have did
Uh-huh.
for this
So
IOU. Okay.
yeah. So IO Uring is pretty specific to Linux, but they do something else, which is they use this iocp calls and all. So they have something else. Maybe they do not have especially IO Uring calls, but they have iocp, which is like pretty similar to what IO Uring does, right? And we'll take a
Yeah.
look little bit on today also in about iocp, because it makes sense, because both works similar, like IO Uring and iocp work similarly, right? Both are pretty high throughput and all. So if you have to make a comparison, you may make a draw parallel between the IO Uring and the iocp, not between the EPOL and iocp, because EPOL is a less one level below the IO Uring, right? Okay, I will take a look at the iocp a little bit as well today. Okay, so these are the two major differences that IO Uring uses to make it more throughput and less latency, right? So remember this: less system calls and avoiding unnecessary copying by having some memory which is shared between the OS and the user layer, right? Correct? Moving on. So this is the little bit of theory that you should understand before writing the code of IO Uring. Okay, so some more. So what happens is in IO Uring, there are two, three, same as EPOL and all. You have to understand two, three system calls that you have to use while using IO Uring. So before you understand the system call, you have to understand these two things. So whenever you set up the IO Uring using their initialization methods, they set up two buffers, and those buffers are actually queue in ring buffers, right? You understand ring buffers, right? So that's why if you see now, its name IO underscore U ring. It's a ring buffer that it creates. That's why the name input output underscore U ring, right? Okay. So what are these two buffers called? So one buffer is called submission queue, and the other buffer is called completion queue. So these are the two buffer, basically two queues, which is in a ring. It sets this IO Uring sets up, right? So in submission queue, what you do is in using IO Uring calls, you tell the OS that I want to do some kind of operations on this particular socket, and you put in that queue, right? You have one structure, you place every data in it. Okay, I want to do a receive on this particular socket, and I want to read this much data. You put it inside a structure and you push the data inside a submission queue. Okay. So whatever operations you want to do, you put it inside the submission, push inside the submission queue there, right? Now, once that operation is finished by the OS, remember, we don't have to take care of finishing the operation the way we used to do in EPOL. You just tell ki this operation I have to do to the OS. OS will do all the operation. It will take care of everything, like how much data I have to read, everything. And then once that call is finished, once that operation is finished, the OS will submit a packet onto the completion queue, right? So OS here will submit a structure on the completion queue. So what you have to do as a user is you have to keep checking the completion queue, right? So if you'll keep waiting on the completion queue, if any operation has finished, you'll take out from the completion queue and you'll know, okay, this data has been received, or you'll take the result of that operation. So these two queue you have to remember. One is where you push your what operation you have to do, and the completion queue is where you will take out the data. Okay, my this operation has finished, and what is the result of that operation? Is there any confusion between this submission queue and completion queue? So completion queue is getting used by OS to push the completion data, and submission queue is used by us push the data. What kind of operation we have to do on what sockets, or any FD? Is this clear? If it is clear, then we can move on. Submission queue and completion queue. You have to remember this.
One question. So why are they circular queues or buffer? Is there
So
a reason?
that's how they have implemented. We'll have a circular
Okay.
queue. Yeah, that's how their internal
In
implementation is.
case of circular queue, there might be some
Hmm.
loss of information, right? Like there are too many requests.
No, if there are too many requests that comes, and if you suppose there is no space left, right, in the queue, that call blocks. Actually, when you try to submit, no, it will block until there is some available space,
Okay, got it.
right? So OS will block that call. Correct?
Yeah.
Okay. So moving on. So if you have understood submission queue and completion queue, then it's very easy now. So what I'll do is, so there are other few calls that I need to tell you. So now
Amit,
yeah. Hmm.
uh, like inserting into or putting data, putting an entry in the tail of the submission queue, whereas also
Hmm.
reading from the head of the completion queue, both these are
Hmm.
blocking operations.
No, if you are able to submit to the queue, then it is not. It will just submit and return back. This is
Yeah,
not a
but I
blocking
mean,
operation.
if it's full, it will keep waiting until.
If it is full,
Yeah.
then yes. And also remember this. Okay, let me show you the APIs, then I'll tell you what is happening. So these are the APIs that you need to use. You're using APIs. Okay, the first API that you will use is initialize. Once you set this thing, it will set up all the buffers, submission buffer, completion buffers, and everything, right? So this is the initialize that you have to do. And then one sec. So this is the second API that you need to use to get the submission queue. See this, what it is returning. SQE means submission queue entry, right? So it is one of the space available in the queue. Think of it like this. It is returning a structure which is a pointer to a particular space in the queue, right? So it is telling you can actually enter something. So you have to take out the SQE first before you can submit the request, right? So this is the sequential queue that you will use, and then you will prep like this. One second. So before you submit, you have to tell using this. So you will tell, suppose you have to read a file, suppose. So you'll use this API and you will tell for this SQE, remember SQE, this is written where? This will return in this API. So that you will give SQE and on which FD you want to read, right? And the buffer in which the result will be stored and how many bytes and the offset from where and from which offset the file you have to read. So this actually is the API for reading a file. So similarly, there are other APIs like IO using prep receive, IO using prep send, IO using prep write, right? So these are the different APIs that you will use to tell the IO using what kind of operation you want to do on which sockets or on which FD, right? So once you have done this, you'll just say this API. This one. So once I have prepared everything, I'll say now you can submit the request to the buffer. So only thing this guy is doing is telling the OS now I have submitted one request, you go and check it out. So what OS will do is, okay, it will go to that queue, submission queue. It will take, okay, I have to do this kind of operation on this data, and it will the OS will do the operation for you. Correct? So once the operation is done, what we have to do is we have to wait on this particular API. This API. So we'll be waiting on the completion queue. See CQE, which is completion queue, right? And this CQ will give me what? It will contain all result of the whatever the result will be there of that particular operation that you have submitted. It will contain all the result. So you can use this CQE to get the result. I'll tell you how to get the result, right? So this is one, and then there is one more that you need to use. So this is the last thing that you need to use for the urine. So telling this means कि now I have whatever the completion what the OS has done. कि I am done with the okay. Now I have seen the result. You can remove that submission queue, submission entry. So now OS can do is like they can delete the submission entry from there and they can use that entry for other purposes like other submissions, right? Getting so as a user you have to tell ki, okay, now I have seen that result. Now you can remove that. So this API will do that. I'll give the proper API. This is all everything I've given in notes, so you can read it later. So this thing. So these 6 API that you need to work with your IO Uring. So let's see. So this is the init, and let me tell you what these things. So this is not a system call. This is still not a system call. Just see how many system calls we are doing. Now what we are doing is we're taking out the entry from a submission queue here. So this is still not a system call, right? Now after this we are doing a prep read. We are just preparing for what kind of socket and what operation we have to do. This is still not a system call. Let me write this, not a system call. This is still not a system call. Now when we are doing a submit, this is a system call. We are telling the OS ki now there is some entry in the submission queue. You can do it. You can take that entry and do the operation. So this is one system call that we did. This again is not a system call. We are just waiting on to the queue, completion queue. Remember that completion queue is shared between user space and the OS space. So this is still, it doesn't have to go into the OS space to get to receive the entry of that CQE, right? Or even when you are doing a preparation or getting this SQE structure, no, you don't have to do a system call. Why? Because those memories are actually shared between OS layer and your user layer. So these are still not a system call. This is still not a system call. And then when you mark it as syn, this is still not a system call. So you see there in all these operations, there is just one system call that you are doing. Correct? Is this understood what I'm trying to tell here?
I have one question.
Yeah.
Actually, I
Tell
didn't
me.
quite follow. What is the specific purpose of this third call, right? IO Uri preferring.
So I'm telling inside this, if you see, I'm telling, suppose I have to read a file, some bytes from a file, suppose, right? So I'll be telling, so this SQ is, I would have received from this call, one particular entry. So I'm telling
Right.
inside this SQE, I am telling this is the FD. FD will be some file ka FD that you want to read, right? And this is the buffer where the result will be put of the read result, right? And this is how many bytes you want to read, and this is the offset from on the file. After these many bytes, I want to read the file.
What if this is like it's not a file, but rather it's like a network socket that I want to read. So
So
that also
again,
will
what you
work
will
here,
do?
right?
Yes,
Yeah.
yes. So instead of doing a read, you will what you will do is RECEV, receive.
Okay, okay, okay.
And instead of this FD will become a socket ka FD. This will be the buffer on the read will happen. And this is the number of bytes that you want to receive. And this you will not need because this is specific to the file read wala API.
Okay.
Yeah, got it. So this call, no, it is only you are preparing. This is still not a system call that is going happening inside the OS layer, right? You are preparing this. Okay, I want to do this kind of operation on this particular socket or this particular FD, right? So understand this. This is still not a system call. This is a system call. We are submitting the entry into the submission queue and telling OS ki now there is one particular entry into the submission queue. Now you go and take it out the entry and do the operation. So this is a system call. So out of all these 6 APIs, there is only one system call that we are doing in the whole operation. So my whole receive will be finished and there is still just only one system call that will be there. Right? And if you look about the how many copies we are doing, so whatever the result of, suppose we are doing a socket receive, right? So the result of the receive will actually go inside this buffer will copy. So only TCP ka socket ka buffer will get directly copied into this buffer. That's it. And right, this will get copied into this buffer. So this is just one copy here, nothing else. So this,
one doubt in this. See, you told that actually the fourth one is a system call, but others are not a system call.
yes.
So we have an init and get SQE and prepare, receive and all. Assume that one of the, it is anyway the user will do this some series of operations. Then he will come to fourth, right? One, two, three, and then fourth. In case
Hmm.
something gets wrong or he even did not initialize anything, and now we are directly calling a kernel and all, will it have some
So
kind?
you will, so yeah, okay. You will always check the return type, no, if it happened properly or not. Then you will go to the second step.
Okay.
You'll check the return type of all the APIs. That is there in all the API calls that we do in while even in the first class of networking, I said
Correct.
any API call you do, check the return type. Otherwise, it can you never know it can when it did that API call did not finish properly, right? So once this is proper, then you come to second. Once this is proper, then you come to say third, like that, right?
Yeah.
Yeah. So is this clear? Why is this? So one more thing. So one very important thing is here is this particular prep that you are doing, this prep, right? And this, what you can do here is these two calls, no, you can repeat it many times before actually doing using submit, right? So suppose on 4 sockets you want to do a receive. So instead of doing doing a prep receive on each socket and then submitting, what you can do is a batching. Right, you can do a prep on all those 4 sockets and then do a IO during submit just once. So what OS will do is it will come to the submission queue and it will see the all the 4 entry and will take out all the entry and do the operation. So you will get advantage if you do a batch processing here. So think about this. You have to do a receive on 4 different sockets, but there is just one system call that you are doing. Think about the epoll that you will have to do so many system calls for each of the socket that you want to receive. So IO actually tells you, actually if you read about it, no, it will give you more advantage if you are doing a batch processing. Correct?
Yeah,
Is
yeah.
this understood?
I understood it because we can
Hmm.
able to do the batch processing because in the third we have the combination of like socket and also an SQE. With okay, with that it can able to differentiate between the different things, right?
Yes, yes. So basically this call, if you see, no, what I'm saying is this call is only telling the OS layer that there is some entry in the submission queue. Right, so even if you do 100 request 100 prep once and just do a one submit call, that's it. So OS will know, okay, if you it will go, okay, there are some entries that has come to the submission queue, it will take out all the 100 entries one by one. Depending on how the OS work, it will take out all the entries. You don't have to do a IO during submit for all the entries. Getting my point? So these two calls, you can do it all once for all your socket or whatever FD, and then do a IO during submit just once. So this is just one system call for, let's say, 100 sockets, or let's say 100 FDs, 100 file read that you have to do. Are you getting how you can get a better throughput in IO during? So it gives you a way technique to do a batch processing. Correct?
Yeah, but I have a small doubt, Amit.
Hmm.
So,
Hmm.
as I understood, as per this one, okay, we can ask for that SQE for a different sockets also, right? This int FD it could be different and here
Yes,
that is
yes. This
possible.
these two calls will be different for each FDs.
Each FDs. But then
Yeah.
when you come to the fifth one, right, during wait
Hmm.
CQE, here in
Hmm.
this, how can it differentiate between the two sockets?
Yes, exactly. Good question. So how it will differentiate is so if I'll show you this structure, I'll show you one structure, then you will know this copy. So see this CQ structure first. This is how the structure of IO during CQ looks like. So this has something called user data, right? And also if you see the structure of SQE, This is little big, but only thing you need to know is one thing. So see the structures of these two so this is the structure of IO using SQE, right? So in this also, if you see here, no, you have a user data, right? So what you will do is, while doing a prep receive or this, no, you will set the user data. And inside the user data, what you will have the FD, what kind of operation, what you want to do, and any particular state for that socket. So once you have pushed that state, no, while doing this prep receive or prep send, when you will do a when you will receive that some entry has some operation has finished for that particular socket, you will take out the user data that you have pushed in during the submission queue, and you will know, okay, for this FD this operation has finished. Because what OS does is, whatever the user data that you would have pushed during submission queue, you will get as it is in the completion queue. Getting my point? So you can put any data in that user data, whatever the state you want to. Like suppose, remember, we maintain a state during the when we are developing that HTTP server. So suppose in one go were not able to do a full receive, so we put it in the buffer and then we do again receive. Remember that HTTP server implementation. So we can do this. We can put all the state for a particular FD inside the user data, and then we can take it out during the completion queue.
Yeah, Mithun, this I understood because I
Hmm.
saw these things in even this like Windows callback also we will typecast to the
Correct.
user data or SNMP
Yes.
callback or so many there are even in
Hmm.
this one also. I
So
think the
there
similar
has
thing is
to be,
happening here.
yeah, there has to be a way to know, right? For this particular FD, this is the state right now in, or which operation, because this, if you see the completion queue, no, you will not understand ki, suppose you for particular FD you might have given read request also or send request also, receive and send both, right? So how do you know in the completion queue which completion packet is this, whether it is for the send or whether it is for the receive, right? You will only know it through the user data that you will push during prep. Getting my point? Tell, tell me who did not get this user data wala things. This is important actually. Did everyone get this? So if you have understood this much, then, and also one more thing, that if you see here, no, IO using wait CQE. So you will get the event one by one, right? Every time you do a CQE, you will get one event, then you can have to do again CQE. So it will be some kind of forever while loop, that how we used to do in equal wait. Remember? So every time you have to pick one completion packet and whatever you want to do your business logic, right? So there is also a way, instead of doing CQE lot number of times, there is also a API to do a batch, right? You take out in the batches like hundreds of completion packet. I will take it out once and then I'll look ki what all FD and what all completion is there. So that kind of API is also there in IOURI, right? And once you are done with that, you will just tell, okay, I'm done with this particular completion packet. You can just remove it using this call CQC. Means, is it now getting into it, how IO rings is better than ePOL? First thing point is this: you should understand how IO ring is better. Two major difference: less system calls. It also gives you a flexibility to do batch processing, which is big advantage in high throughput systems. Correct? Okay. Okay. So now if we have understood the APIs, so we'll do a simple project that we'll write to see if it is faster or not, right? So what we'll do is we'll create a simple project. Let's call it. I'm directly making this project on Linux. If you see, this is my Linux window that is opened, because this will only work on Linux, right? So IO Uring demo, if I give the project name, I'll take this out. Okay, so I'll need one code. Let's call it IO Uring .cpp, and let me make one more CPP file that I want to show ki without IO Uring, if you do it, how fast or slow it is with the IO urine. So I just want to create one more file. Let's say blocking API, let's call it, right? So IO urine and one is for the blocking API, and then I'll need one CMake file, CMake lists.txt. Okay, and then I'll copy some code to show you. So give me a minute. So you'll understand how to use it also. Okay, copying is not good actually. So int main is come here. All everything goes here. Okay, this is done. What is my CMake lists? CMake list is this. Oh, I put it in CMake list. That's why it is getting. So this is my CMake list. So this is the demo with the without IO urine. Blocking API, I'll put it in. So inside int main, go this side. Inside for loop, you go this side. Okay, so this is for the blocking calls, and one I will take it with the urine. So I'll show you how the batch request can help. So copy this. I'll show you how the code is written. So int main, I code. So for block. Okay, I hope this is done. So okay, so first we'll look at the CMake list. So this is it's like this. This is like this. Add executable VR blocking IO, and my file name is blocking API. Blocking API. Sorry. Blocking API dot CPP. Now add executable for IO urine. So let's call it IO urine and my IO urine dot CPP. IO urine dot CPP. Okay. And then target include directories is this. Target link library is this. I'll tell you what all it is. Okay. So let me see if it is getting built. So I have to be in CD IO urine demo. Make directory build. CD build. CMake dot dot build. CMake dash dash build dot. Some error it is showing. Lot of missing terminating character duration dot something is there. Uh, you see. Okay, let me first go through the code, then I'll fix it and we'll run it. Okay. So first, if you see the CMake list, so to use the IO urine, there is a library that has been provided by the developers of the IO urine, which is called liburine, right? So if you see, if you have to do write all the codes for system calls of IO urine, no, you'll have to do a lot of setups. Like you have to manually do the setup for submission queue, completion queue. You have to memory map the submission and completion queue, everything that you have to do. So what they did is they wrote a wrapper around this, which is called the liburine. So you don't have to do those stuff, right? And people use this liburine only, like for the production codes and all. You will use liburine, right? So how do you get liburing is you have to do if you do a install of this, I'll just show you the command. These are all given in the notes also. So this command you have to do. install liburing, it will install. And then what I'm doing is I'm linking my this iourinca executable with this library liburing.so. Okay. And the include directory, I'm giving it here where it has been installed, my liburing, right? Correct? Okay. Okay. So this is done. CMake list you understood. So in blocking API, what I'm doing is what I'm trying to do is I'm reading a test file, which I will do around which will be around, suppose some big file, suppose some 10 MB or something. I'm reading that file, and I will read that file, let's say 10,000 times, just for the sake of like showing ki how fast your liburing can be, right? So it might not show you speed if you do just one read one simple file, right? If your non-Uring code or the blocking call will give you more speed because a lot of setting up and all we have to do for the IO Uring, right? But if you do a lot of reads and for the big files, so that's what I'm trying to replicate here. So I'm reading 10,000 times the same file and I'm checking ki how much time this is taking, right? So this is some blocking call that I'm using. Simple, no IO or anything. Simple how you read a file, right? Yes, correct. So inside iouring.cpp, what I'm trying to do here is, again, I'm doing the same thing. I'm trying to read the 10 MB file, same file I'll read, but see these calls. So I'm using iouring. So how to use it? First, you will give this ring and you do a iouring in it. And you will give a queue depth. This is the queue, this is the size of queue that will be made. So suppose you can give it like this. Depending on how high throughput and all you want, it is a trade-off that you have to do. So bigger depth means more simultaneously connections or more simultaneous operations you will be able to perform, but then it will take more memory on your system. So this you have to analyze which queue size is better, right? Remember completion queue and submission queue, this is that size it will create in when you do a init, correct? So this is init you have to do. Okay, so this is should not be here. Okay, so now what I'm trying to do is I'm starting the clock now to read the file. And what I'm see this code, what you will see properly, this code, instead of reading 10,000 times like this, you can do it like this also. You can do a this. You can take out the submission queue ring, SQ, remember, you have to take out a SQ entry, and then I'm doing a prep read to read the file. So what I need to do, give SQE FD, which is opened here, open file, test file, and then buffer. Buffer is how many data you want to read and the size of buffer, right? And then once I've read it, I'm doing a submit. You do so. Why I'm doing inside the for loop? Repeat. This is the batch processing I'm telling you about. This is the batch processing I'm doing. Can you get this? So think of it this like suppose this batch number is supposed 32. So I'm 32 times I'm preparing for the read, and at once I'm doing a submit. Right? And in one go, I'm doing a submit for all those 32 requests. Right? And then for that those many requests, I'm doing a wait CQ, and then I'm doing a CQ scene. That's it. Whatever I've told you, this is how you will use the IO ring. Right? Any confusion here? Any confusion? These code are all given notes. You can also see it once. So this wait call is, yeah, it is a blocking call if there is no entry in the completion queue. If there is even one entry, it will return back with that entry. Correct? Okay. So what we'll do here is, let's see if
Amit,
anybody.
in the for loop, in the second for loop, right?
Hmm.
Again, you
Hmm.
are doing this wait CQE also in like batches, is it?
No, this is not in batches. I'm taking out each entry again and again for the entry. This one. This is not a batch thing. I'm
Okay.
seeing one entry. I'm telling, okay, I've seen this entry done. I'm taking one entry, I'm telling, okay, it is done. Like that.
Because
This
I
is not
see
batch.
that you have written I less than batch.
Hmm.
Uh,
So how many batch requests I gave, no? That many times I am doing a sequence, a scene,
I see. Okay.
right?
Mhm.
Okay. If you see here, maybe this code was already there somewhere. Let me check if it is there. Some kind of messed up copy paste has happened. Let me see if it is already there. Open folder, hiring demo. I think so. The same code, I'll show you also. This is the same your CMake list. Same thing. Any confusion with this? This is some code that I've written to process in batches, right? So this is the whole total reads is, if you see, it is still 10,000. The same as blocking, how many reads we are doing. And then this is without blocking. So let me see if it builds. So cd build, cmake, what has happened, cmake dash build dot. So if I run the non-blocking wala part. So what is the name? Blocking. So if you see here, the blocking reading the same file 10,000 times. I have the file here. If you see here, I have this test file here, this test file, right? This is around 10 MB file, and both are reading the same file only one by one. So there are two executable that I have created. One is blocking IO and other is one IO using, right? And both are trying to do the same thing, but one is with the IO using call and one is other blocking calls, right? So the blocking call took me 0.02 seconds, right? Let me see how much IO using takes. So IO using is taking 0.007 seconds to read the same file in batches. So this is somewhere around 4 times if you see, right? Correct?
Yeah, at least 3 times. 3 times.
3 times. Yeah. If you keep on doing now on different machines, it might give you a better advantage also if it is running continuously and all. But this is something that I want to show you. You can get a better result with IO using. You can also check with the epoll key, with the epoll how much faster it is, right? The more throughput and more scalable you want, it will start showing you more better results. For simple thing, if you'll start using it, no, it will not give it. In fact, it will give you a bad result only. If I'll not do a batching and all here, no, it might go and even show less means bad result than even the blocking I also. So you should also know when to use it and when not to use it, right? So if you just have to read a simple file and use it like in your code, don't just directly go for IO using. Do a simple read only. It is only when you really need some very high throughput in very high throughput systems, right? Then you should think about IO using and all. Correct? So moving on, how we can leverage this in our HTTP server library also. So I'll directly show you one code and I'll go through it. Right? We'll quickly finish this up. Or I directly show you in my TCP server that code I have written. What do you say? Okay, if I copy this, let me create a file and show you here. I'll walk through the code. Let's call it IO using server. Maybe the copy will be messed up, I think. Yeah, a little messed up. Wait, I'll do one thing. I'll copy this in my window local, then it might not be messed up. This is my local system. No, this is not my local system. This is my local system. Yeah. Okay, so if I have to copy this, I'll show you iouring.cpp. Copy this and then format. Okay. So if you see this, I'll quickly trying to run through how we can use this in our TCP server, how we can make our TCP server even more faster than epoll wala thing, right? So what we can do is, see, I am defining some operation, ki what kind of operation I want to do, send, receive, accept. And then this is the client socket. Remember, we'll set the state while doing submission queue and the completion queue. So this thing I'm gonna use that state for that. I'll understand ki when I'm setting my FD, what kind of uh, what kind of FD I set the and what kind of operation it was for, right? So these are all same thing, Linux server and all. Whatever the IO uring difference, I'll directly show you this. So this is for the setting up IO uring call, which is IO queue init. See, I'm checking all the if what this API is returning and all. If it returns, I'm exiting. That my code should not proceed only if queue is failing, right? Right. So this is how
Yeah.
you should actually write in the production code. You should check the result of all the APIs that you are using. So initialize and all are same. What I'm doing here is, once I have bind and I've taken, I'm prepping my this particular server FD for the request call, right? So you have IO using prep request, except, and this SQE I'm using and this particular FD, right? Right. And if you remember in the server FD, we do not need any particular result like any buffer and all. So I'm putting it as null. You can check this API, what all it accepts, right? And then if you see, I'm setting the SQU user data as OP accept or this particular operation. And then I'm doing a IO using submit. That's it. So the very first time during initialization, I have put this rep accept this server FD and I put it in this using submit request. So what will happen is, in the start, I'm waiting into this IO using wait CQE. So if any client connection comes, my my OS will be do accept. I will not be doing accept now. I just have prepared the accept and given it to the OS. You do the accept now on this FD. So I'll be just waiting on this completion queue, right? The moment it returns, when suppose a client connection comes, though, so at that time some completion event, the OS will put completion event, and this will return. And I'll check if return is less than 0, then some problem has happened. I'll continue with the wait. And otherwise, if some data has come, I'll just go there and I'll do handle IO event with this particular CQ. I'll push it. And then I'll tell IO using CQ is seen. Okay, I am done with this event. And inside handle IO event, what I'm doing is I'm checking. So CQ will user data I'm checking. Remember in CQ, what we have pushed, the operation, the FD on which I'm doing. So inside user data, I'll check, okay, whether it is the case of accept, whether it is the case of receive, and whether it is the case of OP send, right? If it is accept, this is important. But if it is accept, remember the result of accept is what? What does the my simple accept, when you do accept, what does that return?
It
What is
returns
the
the client socket, like the
client FD which it has connected to, right? New client socket. So whenever, whatever the operation you have told OS to do, you will get the result of that operation inside this CQE RES. Remember this. So suppose you have given to send, right? Or receive, right? On particular socket, you have prepped it for receive. So what you will get it in CQ RES for that receive wala, if you have prepped, what you will get in CQ RES?
you will get the number of bytes you have received, I guess.
Correct. So receive call gives you what? What does it what does it return? It gives you the number of bytes you have actually received, right? So you will always get the result of your whatever the you prepped it for, no, what the result, whatever happened with that call, you will get it in this CQ RES, right? And
And
what you
in
will get
prep
in user,
receive, I think in prep receive, you must have put that buffer. So in that buffer, you will get the actual data. Is that the way?
yes,
Right?
correct. So
Yeah.
if you, I'll show you. So see, I'm doing once I have accepted, I am doing a prep receive on that client socket now, right? So what I'm giving prep receive, I've got a new SQE. In that SQE, I'm giving this client FD. On this, I have to do a receive, right? Client FD receive. Remember, receive call. On that, I'm giving a new buffer and the size of buffer and then 0, right? And then I'm putting user data as what? It is a, for this client FD, I'm doing a receive call. So that next time when I'm doing a completion packet, I know it is whether it is accept or whether it is receive and for which FD it is. So whatever you put in the user data, you will get as it is in the CQE user data. So this is something that you'll use it to maintain the state. So this is for you, for the user, to understand when we take out the completion packet, what it is for. So to understand this, you while doing a prep receive, you will push this data inside the user data. So these two are important. User data, what you are pushing, and then CQE result. What is the result of that particular operation that you prepped it for? Correct? Is this understood? Got it, right? So if you would have received something, this is copied is wrong. Yeah, so if suppose OP received, you would have got completion queue. If you would have got something for receive because you would have submitted previously for receive. So what you will get is how many bytes you received in RES because result you get in the RES CQ RES and on which FD it was for. So you will get it from the CQE user data, right? Because while submitting also we have put it the client FD for in the user data and the bytes received you will get it in this one. This client FD and buffer. So this buffer is in this particular buffer should be whatever you have pushed, no, there you should have got that buffer, this particular buffer. So this is the buffer that the data will be pushed inside the OS will put the data of that particular whatever you have received in this buffer. I might not have written the proper code, but did you get the point? How everything's IO Uring and everything is working and how it is giving you a better throughput. Tell me if there is any confusion around this IO Uring. Very, very nice concept that you can use for any file FD, reading file FDs, or for all the socket receive and send that you can use IO Uring. Any confusion around IO Uring calls and how can you use it? Tell me. Yes. And I have given properly in the notes. So now if you give it a rate, I feel that if you have understood it now, you can understand properly. IO Uring everything, what API calls and everything.
Is
Correct?
it, I mean, do we have to always do the homogeneous preps? Meaning, should I have to, let's say, on a socket FD, if I would want to do accept and send, can I do those heterogeneous preps as well? Or,
What do you mean by heterogeneous
I
prep?
mean, once you're doing the during these on the socket FD, you actually did a accept, if I'm not wrong now for now, right? So on the same socket FD, if I would want to prep the IO ring for the send as well.
You have to do a prep. Yes. Otherwise, the OS will not know. I have to do a send on this socket also. So that
So
socket ka send will have a separate entry in the
and
submission queue.
so for that, can I do it in a batch and then do a submit or?
Yes, yes. You can do a batch.
Okay.
So you will have n number of times you can do a prep and then can do a submit at all at once. Because every time you will do a prop, you will take out one SQE, right? Remember this, you will take out one SQE and then you will do a prep on that SQE. So every time it will have a different entry. So once you submit, entry you are doing here only. The only thing is submit, you are telling OS now you have some entry, you start doing the work. Clear, right?
But now I'm thinking, now if you'd want to send for the multiple client sockets, you will have to do submits equivalent to the number of client sockets that are available, right?
No, you can do a prep for all the clients at once and then do a one time do a Uring submit. If you
But
have
in
all
that,
the clients already there.
yeah, but in that case, I should have some weight mechanism to consolidate all the client socket connections and then do.
So yeah, correct. So this is what happens, no? So this is actually very this is technique that is used like in production everywhere, right? See, in database calls also, no?
Mhm.
If you see the database calls, if you have suppose hundreds of requests per second, it is going to the database, which is not very good way to do, right? It is a network request that is going to the database. Suppose it is MySQL or something, right?
Correct.
So instead, people what they do is, instead of sending 100 requests, one request each time, like one request went and then came back, one request. Instead, they what they do is they prepare in batches, like 50 requests they will do in batches and then send all the 50 requests at once.
Okay.
Right. So this is very good. Batching is a pretty known technique in the productions. People use it to get optimize it for the better throughput. So here, how we are getting how batching helping is that we are not doing a IO using submit every time. And IO using submit, why we are trying to avoid is because it is a system call, and system call takes time. So context switching and all happens, right, when you do a system call. Yes.
Yes.
So just one more optimization on this IO using. Does anyone know or any idea what one more optimization that we can do on IO using in this code also? On top of this, one more optimization we can do to make it even more faster, right? So this IO using concept came from uh, Linux 5.1, right? But there is one more concept called SQ poll, right? Submission queue poll. So how do you use this is like this. So during setup, no, and I'll tell you how it is making it even more faster. So I'll just show you how this call looks like. This is all given in notes, you can read. So when we remember we are doing in IO using queue init, right? Instead, you can do initialization using this. So you are using a param. Inside param, you are giving a flag IO using setup SQ poll, enables SQ poll mode, right? And and then you are doing init using this particular param. So if you initialize your IO using this, you are actually enabling a mode which is called SQ poll mode. And this has come from Linux 5.6. This is not from 5. So IO using calls are from 5.1, but this particular mode has come from Linux 5.6. Remember this, right? So your Linux should, to use this mode, your Linux kernel should be 5.6 and above, right? And what does this do is, it is at whatever, remember we are doing IO using submit system call, right? So if you initialize your IO using with this, you are telling your OS that you keep pulling my submission queue yourself, that if there is any entry or not, I will not do IO using submit system call. This is how it is making a more advantages. So instead of you doing a system call, that system call is also eliminated. Getting my point? How it is even one more step above optimization is there. So now your OS is doing a polling on your submission queue. Instead of what happened when you do a submit, you are telling OS that now you go and check whether there is any entry in the submission queue or not. But if you use this particular mode in the IO URI, you don't even have to do IO submit system call. You in during initialization only you are telling OS you keep polling my submission queue if there is entry or not, if there is entry or not. So you are even avoiding that system call, IO submit wala system call. So one step more optimization. Correct? So that brings to the end of IO using. This is all you have to know about IO using. Correct? So tell me if you have any confusion around IO this IO using calls. Yes, no. I'll delete this file anyway because everything is given in notes, so you can read. So can we move ahead? Move ahead. Yes.
Yeah.
Okay. So okay. So because we were talking about the IOCP, so at the beginning of the class, I told you that if you have to drop parallel on the Windows system, you will talk about iocp. If you are talking about IO during calls on Linux, there is thing called iocp on Windows. We have talked about this previously in one of the classes also, right? So on Windows, we have iocp to make it have your whatever the code you have written, no server and all, to have high throughput, you can use iocp, right? So IO during is not on Windows, so you will use iocp calls. And if you have understood now IO during calls, it is pretty much very similar to how IOCP also works, right? So if you have seen the code and all, I have already implemented some of the code in IOCP in the Windows server. So I'll just tell you quickly what all you have to do to use IOCP in Windows, right? And I've also given proper notes on IOCP on Windows. You can check that out also. So what you have to do so again, the same thing. I'll first tell you a little bit of theory quickly. So in IOCP on Windows, what happens is IOCP is actually called IO completion port. So what happens is you create IO completion port the same way that you are creating the IO during a queue and all, no? So you just tell ki, I want to create a IO completion port, right? And you will use this completion port to submit an entry to the OS telling ki, okay, I want to do this particular operation on this particular socket or FD, anything. On Windows side, it is actually called handle, right? On not there is nothing called FD or file descriptor concept on Windows. You actually call it handle, right? So handle for a file or a handle for any other like sockets or anything, right? So same concept. You create a IO completion port that is called IO completion port, right? And you associate the IO completion port with a particular operation on particular FD on handle, right? And then what you do is you will wait if that operation is finished using call let me get the name. I forgot the name. The call is called wait for something is there. Create IO completion port. I would have written here.
Wait for IO completion.
Wait for something is there. Wait for something. Wait 1 second. What is that? Wait for IO completion port. So there is something called, I forgot the name. Let me check. What is that called? So similar to that we are doing now, wait for queue or something like that. There is something called wait for, see this one. This one. Get queued completion status. This call. Can you see? So this is same key. If you have process is finished, if that operation what you have associated, the IO completion is finished, this will call with the results of that operation. You are not doing the operation. You are just telling that I have to do this operation. And the OS will do the operation for you, and then you will wait on this get queued completion status, and you will get the completion status in here, and you will see the results inside this, how many bytes transferred. And this completion key, no, remember we have user context in the IO during what we talked about. Whatever the IO user context you will set during the submission, you will get same thing as in the while when you are doing a completion. When you check this completion key is doing the same thing while doing a prepping it for the send or receive. You will set your state in the completion key, and you will get the same whatever the completion key you have set here, you will get inside this completion key. So see, I'm taking out the, while prepping I would have set my socket and all. So while getting the completion, I'm checking out, okay, this is the socket for which this thing, this process has completed. Similar, right? The code and all is given. If you go and see the code on the server side, no, on GitHub that I have pasted, it is there, right? So if you read it once, it's a similar concept to IO Uring. That is IOCP code on Windows, right? Okay. Yes. So with this, I will say I'm wrapping up all the concept that I had to tell in this cohort. So tell me if you have something to ask, or otherwise we'll talk something. So this comes to an end of, this is the end of this cohort.
Yeah, it has been very nice, actually. I mean,
Yeah.
it's really, very good thing, because the many of the things in advanced C++, networking, we did not
Hmm.
know actually. At least in
Yeah.
this okay, networking side, the other
Hmm.
multi-threading and all we know, but you have actually taught, how to do that in a
Yeah. I hope
very,
this is useful. Only my only good feedback I will feel if somebody gives is, yeah, this has taken me from this level to other level. I did not know this and now I know this, then this is a good feedback for me, right?
yeah, it's really correct. That is right. Yeah, obviously.
Hmm.
Yeah.
Actually, in a very short span of time,
Hmm.
I like this particular format a lot as well. It's like a boot camp or a workshop
Yeah.
kind of thing, right? Very short span of time you learn, and then you
Even
can.
if I keep a big format like doing it for 5 days a week for 3 2 3 months, what mostly I'll be doing is writing the code in front of you mostly, right? Because all the concepts I've covered, but still you will learn only that much. Even if I code, no, you will only learn when you code. So
Yeah,
it
yeah.
doesn't make
Learning
it
is, I
does
think, yeah, it makes only
it doesn't
when you
make
code it
sense if you
yourself.
just
Yeah,
see me writing the code in front of you.
yeah, totally
Because
agree.
right, whatever the code and all, it has to be there. I have given you whatever the concept it has to be taught. I've taught you. Only thing is now you have to sit and try to code. That's it.
Amit, I have given my feedback to you in the form you just sent.
Thank
But
you.
on top of that, what I want to add is that what was best is how you kept it interesting throughout.
Mm.
Like you first created the problem, you showed how it can be solved, then how it can be solved even better, and then what is the best way of solving it. So that is what kept it very interesting and hooked us.
Yes. I mean, my idea is anything if you have to learn, you should always understand what problem I'm trying to solve with this, right? Other, what's the
Exactly.
point of learning?
Right.
Like
But a
here
lot
is
of other
here is
YouTube videos,
iocp.
yeah, a lot of other YouTube videos, they say that okay, we are learning this, but
Hmm.
aage piche ka, the those links are missing, so that makes it less interesting. Yeah.
Correct. Correct. Okay, nice. What about others? There only I listen from 2 3 people only. What about others? Hello. No, okay. So if nobody has to talk, let's talk something more interesting now for few minutes. Let's talk. Let me create a new project. Let's talk few interesting things. What could get asked in interviews and all, right? Are you up for
Sure.
it?
Yeah.
Okay, let me
Yeah,
create some
Yeah,
project.
pretty much.
Okay, now you guys have to answer. I'm just keeping it for fun, right? Okay. So let me add a class or no item. CPP, let it add. Okay, so I'm writing some code. You guys have to tell me what is though this could give you a better understanding of few things. Let me see how many of you guys understand it properly. Okay, so int main. Let's write some boilerplate code, return 0. Okay, so suppose I have one class, right? Class A. So this has nothing to do with what I have taught till now. This is something that I want to understand if you have all your basics correct with CPP, right? So suppose I have a function. So let's call it, let's say it is a virtual function called func1, sorry, virtual void func1, and let's see out something. Let's call it class A func1 handle. And similarly, let's say we have one more function, virtual void func2, and see out. Let's call it class A func2 handle. And let's say we have one more class, class B, and public. Let's copy these two functions. Let's copy this one also. And let's call it class B func2, and this is class B func1, correct, right? And now if I in main, if I want, I can do it like this, right? A star, suppose I'm creating for A and new B.
Does B inherit from A?
No, it
Inheritance
doesn't.
missing.
It is not inheriting by
Oh,
choice. So
okay.
tell me if it
Okay.
is proper. It is not proper, right? Because it will give you a compilation error. That everyone
Yeah.
knows, right?
Yeah.
Right.
So what if I do this? If I, by somehow I'm trying to uh, put it inside this. So let's call it reinterpret cast I'm doing. And I'm casting it to A star. Now tell me if this is proper or not. Can will this give compilation error?
No, it will compile.
It will work.
Okay. So
Yes.
what will be the result of this? What output I will get if I do a of func1?
Class A func1.
Now
No,
tell me.
I think class B.
See the whole code. Let me remove this. Yeah. Check this code and tell me what output you will see on console. I mean, don't type the code and check the output and then tell her. Tell me.
Yeah, I think it
I
will be
think
class A func1 because we are
Hmm.
reinterpreting B as A.
Hmm.
Yeah,
Okay.
so
but
So A
still
func1, everyone's answer is A func1.
I
I
think
would say
B
I
func
think it
one.
will be
B
B
func
func
one, I
1 and
feel,
B func 2.
because the object is.
Yeah, the instance is that of B. I still feel I'm not very aware of reinterpret cast.
I also feel that
No,
a
it's
class
not.
B func
If
one.
even if I do it like this, if you are thinking ki reinterpret cast is some problem, I can do it directly like this, right? This will also work.
right. Yeah. No, so as somebody said, the object, the memory is still there and it is pointing to a V table, and the V table pointer belongs to A or B
Okay, so
is the
I'll
question.
run and you'll see the output, and then you tell me ki how this output came. Then tell me. You see the output. Run it. Huh. So see the output.
Okay.
Class B func2. I am calling A ka func1. I am getting output as class B func2. Now tell me why. So my output is class B func2.
is it because func2 was defined before func1 and B
It could
table
be,
is
but I want the proper answer. Why the output is like this?
It's because of some addressing.
yeah
That's
in
it.
virtual table func2 comes before func1.
Which
So
whose virtual table? A
class
ka or
B
B?
B ka.
class B.
Hmm. Okay.
Yeah,
So
so
explain what might be happening
so
to
since we
get
are
this.
calling func1
Hmm.
and the object is of B,
Hmm.
so it will point. So func1 is on the top of virtual table for class A,
Hmm.
and func2 is on top of virtual table for
Hmm.
class B. And
Hmm.
since the object is of class B, it is pointing
Hmm.
to func2. Like this is my understanding.
Yes, correct.
Oh, okay.
So this is the
Wow.
correct understanding. So what happens is so the moment it sees virtual, see what would have been happening here. The moment you are trying to call A ka func1, it will check, okay, func1 is what? Func1 is a virtual function, right? So because it is a virtual function, it will actually, the moment it sees at a virtual function, it instead of calling this A ka object, it will first check what kind of pointer I am having. So I am having pointer of what? B, right? So it will actually go to the virtual table of B, right? To call its func1. But instead, how virtual table works is the functions has been put in memory addresses, right? So for this virtual table for class A, func1 would be first, then func2. For class B, how the virtual table will be func2 first and then func1 first, right? So the moment I'm saying func1, it will check you, okay, I have to call the first function in the virtual table. But the virtual table of what? B. The first function of virtual table of B is what? Func2. So that's why it is calling func2.
So
So
if
all
class B was inheriting from class A, it would have called properly class B func1.
properly. This is only because you have not inherited.
Okay.
See, if you would have inherited, no, in B ka virtual table also, even if you give above and above func2 doesn't matter, it will keep func1 as the first one. So it will properly call func1, B ka func1 only.
Aren't addresses mapped by some address instead of just indexing like first or second?
No, it is this is how the virtual table, or this is how the compiler is working. It will just check you, okay, this is the first function that I have to call. That's it. Indexing.
So V table has two fields. One is the ID and the other is address.
One is the
ID and the other one is address.
what is
Okay,
ID
subscript.
containing?
No, sorry. Okay, so ID is managed through subscript only.
Subscript is there. That is vptr will be having as a member variable.
Yeah,
Right.
no, so the V table will have a subscript and the address. So now it will go to 0th subscript and access the address, which will be function 2 address. So that's
Yes.
why it is okay.
So if I give public a, no, so in its v table, it will first keep the func1 and then func2. But
Correct.
because I was not giving public a, no, so it is now independent. Whatever you give first is putting in the virtual table like that. Right. So if I give
this is great actually, but I have a small concern with this. Is this worksheet
see,
now?
this is proper now.
Sorry.
If I give a public a, because if I'm inheriting, now you'll get the proper result, what you are expecting. Class B func1.
Sorry, I did not understand. Where public? Okay.
So
The
now I
inheritance.
am inheriting. So
Okay,
in the weak virtual table, the first function will be func1 only, not the func2. So that's why it is giving big a func1 as the output.
Okay, but I have one thing. If it is not inheriting, and see, although we made it as a func1, we are calling, but it eventually called actually func2. What about if this is actually private? Then if it is calling like a private function, it is not some kind of a security issue.
This one?
No, not
like
that.
this.
Let it be. Yeah, correct. Oh, in this time, what happens?
So if we call, will it be able to call?
I think it
is able to call.
Yeah, this is what I have, because we are able to call the actually private function of func2. That's what actually outside that class, that is okay, we are in the main, we are not supposed to able to call this only, right?
Yes.
Yeah. So this is the hack, no?
This is the hack.
So that's why they say that you should not use reinterpret cast. Reinterpret cast itself means that you know what you are doing.
Yes. It is dangerous. If you know what you are doing, then use the interpret cast.
In what cases practically it is used?
Yeah.
In what cases it is used practically?
Reinterpret cast. So reinterpret cast, suppose you have a structure which is taking suppose integer, right?
Okay.
But you want to put a structure into it, like some structure, and you want to put inside the integer variable. So you'll reinterpret cast to the integer, and then when you take it out, you will reinterpret cast back to the structure. So this is one of the use cases that you use. Mainly this is used in embedded system, and all this is pretty much used. In fact, this is actually used in our here also. Windows CPA code that I was showing, na. This if you go there and see this per IO data. Just check this out. In the per IO data, no, there is one place where it takes int 64, but you can put a structure inside it. So in that cases, you need to do a reinterpret cast.
Amit, to say that this reinterpret cast is very common in the callback. So when you have that you have a UI, a window UI, which is some dialog param or whatever, and you have that means a callback, right? So the actually the window callback, when it comes, you when you click on some controls where you have Win32 dialog. So then every time we will always reinterpret cast with one of the callback structure. I'm not remembering it, but this is very common.
Yeah. Reinterpret class is
This is
common.
very
Only thing
common.
is you should know what you are doing is the main thing.
Exactly.
Correct.
Exactly.
Okay.
Even in the socket also somewhere, I am not very remember some some kind of a socket callback whenever comes, or SNMP callback. In everywhere, the user data or whatever, we will always reinterpret.
Yeah. Correct.
And that is the only way to do only. Otherwise, you can't get the actual data passed actually.
Yeah.
But
So
is there any condition that at least the function name should be same? Like, or else whatever function is there in the first entry, that will be called.
function name will be no. But if
Function.
function name is not sent, then it will just give compilation or error only. No, that there is no func1 for a.
No. I'm not saying like function is same function name in class A also, right? But in class B, I'm giving some other function name.
So let's say suppose if I give 3 and 4.
Yeah. Now you are calling func1. So what is the behavior?
Let's see what happens.
Same behavior,
3.
I think.
Function
3 will be called.
Okay.
And if there are no virtual functions in B, then
if
compilation error.
Then it will crash.
This one is not virtual, is what you are saying, right?
Both. Yeah.
Let's see. If it is not there, then it's not.
Should crash.
Crash. Yeah, correct.
Okay.
Because there is no V table and it's trying to access the address of the 0 thing which is not present. So
correct. So V table has to be there. V table is actually playing the magic. Right?
Yeah, I think Pooja was asking. So the thing is, the V table doesn't store by name; it only stores by address, and address also with subscript. Not even that map like 1, 2 or something like this. So that's why this explains this behavior.
Yeah.
So sorry, I didn't quite follow this. A has func1, is it? A when you did A has func1. Then why didn't it work?
Which one?
So when you say A star A is equal to new B, and then A, exactly. So why doesn't this work?
So now you don't have a virtual function here, no V table, so it is not able to access anything like that.
Oh, you don't have you removed virtual. Okay, altogether.
Yeah.
Okay.
Yeah. Okay. So let's see. Simple question. So suppose I want to do this. Right now, though it will happen. But suppose if I have integer, let's say call C, and if I create an object of C object, can I give like this?
Yes, we can.
Not int C. Okay.
How? So right now it is giving me compilation error. So how can you make this statement correct?
By casting it.
Yeah.
Reinterpret cast.
Static underscore cast.
But again, you need a pointer.
Reinterpret cast, because like C only has one int, and you're just trying to copy it into C.
Can assign new C of passing some integer number.
No, I want to make this statement correct. That's it. I am not touching this statement. So what I need to change in this class?
Explicit.
Explicit
will do what? Even if I do explicit, what will happen?
No, not there. In explicit underscore cast of OBJ.
No, explicit the constructor only, no?
In the constructor, you are saying I put explicit.
No, conversion operator.
Correct. So what conversion operator?
Int. Operator int.
correct? And return maybe suppose A.
Yeah.
So because it is giving error because we need something, I have given a constructor. So suppose this. So see, the error is gone. So now what it will see is the moment you are seeing object, it will call this int wala operator, overloaded operator, and it will return A, which is like 2, and C will have 2 here. Correct?
Right.
Right. This
And
was
if
asked to me
and if
into it once.
and if we give explicit for the constructor, this operation should not be allowed, right?
No. This is nothing has to do with that. I will tell you what you are saying.
That's the
So
other way around.
Okay, that's
suppose
the other way.
you have this object 1 equal to 3, suppose.
This operation would be
Yeah, for
not
this.
allowed. Yeah,
So
yeah.
this operation will go like this operation is okay right now. Right? The moment I give explicit, this will not work. Now it will see. Now see, it is started giving compilation error. If I remove explicit, it will not give me compilation error. Getting my point? So now you are telling the constructor, don't do anything by yourself. Be explicit. So I will not be able to, my compiler will not be able to convert this 3 into a seek object itself because I have given explicit constructor. So only way I have to do is if I give it like this, see something like this.
What
Getting my
explicit
points?
keyword does exactly?
So it is telling, it is actually telling a compiler, don't do any kind of conversion yourself. So if I don't give explicit here, if you see here, so what it will do is compiler will come here and it will check you, okay, this is object 1, I have to put this in. So can I somehow change my 3 into some kind object of C? So it will see, okay, if I pass 3 here, which is one
I
parameter
see. Okay.
constructor,
Okay.
I am able to convert it into an object. It will convert it into an object and then it will assign it to object 1. So it is compiler is doing that things for you. But
Okay.
sometimes you don't want this. Like
Yeah.
if somebody by mistake writes this, you don't want the conversion to happen. So in those cases, you will write explicit.
Especially this is used in if conditions where you want to do double is equal to, but you put 1 is equal to and that compiles. So you can avoid that kind of compilation.
So that's why you need explicit constructors, right? Why explicit is needed?
Yeah. Amit, one more, actually a small follow-up question with this 45 is there, right? Int c is equal to obj. Since you have added this operator, then it got worked. But
yeah,
in case if the class has two different data types, like say int a and float something, float b and all. So either we can decide only one to return, right?
yes, it
Both
is
may
you.
not be
You have to
possible.
decide. It is your algorithm that will go here.
No, any one of them I can decide. But the both
Yes.
return, it's not possible. Suppose if
No.
I have a float b is equal to some obj, then like means whatever defined in this class. So let us say in class C, you have also defined one more float
So
b.
let's say you are telling float, suppose
B.
what B, right?
Yeah.
Like this.
Yeah.
So you will decide what, but inside integer you will not do. You will again have to write operator float.
Oh, this can be done, right? Because yeah. Right. Yeah.
Like this.
Correct. This you can do. Yes. Yeah. Thanks.
Okay. So these are so int and float, double everything. These are not just the data type. This can also act as an operator. So these are called overloading of the operators. So these are int and floater. These are not the data type here. These are the operators. The same way that you overload plus operator equal to operator, you are actually overloading the int operator. Correct?
And these don't have a return type to be mentioned here?
No, you don't have to. So when you do a overloading, you will understand ki you don't have to give a return type when you are overloading operators. Correct? So every operator has a specific signature how to overload. It's not like it is pretty generalized. So suppose how we'll overload the equal to operator. So this is the signature that has been given. You have to adhere to that signature.
Got it. So one more question I had. So similar to the above question, right? A and B. So is it possible to cast a parent object to a child pointer?
Parent object to a child pointer, yeah. But anyway, that is to done, no? That is done properly. So you are saying suppose B is the child object, right?
Yeah.
B is like this, and what we are doing is new A. New, suppose A is the parent. That's what you are trailing, right?
Yeah. Yeah.
Right. So this is, so you don't even have to cast. This is happen by default. Oh,
No,
sorry,
right.
sorry,
So
sorry, sorry. No,
yeah, the
if the
opposite
B is
is
the
by default.
opposite is
Yeah.
happen. If
Yeah.
you have
That's
to
what.
do this, you either have, there are two options. Either you do a static cast or you do a dynamic cast. There are two
Okay.
things, right? So either you can do this
What is this case? This is upcasting, is it? B to A?
upcasting. Yes, yes. This is
Okay.
upcasting. So either do a upcasting like this, which is not a safe. You know ki what you are doing, or even you can do a reinterpret cast because that is still available for all, or you can do a dynamic cast here, which is a safe option while when you are doing upcast,
Mm-hmm. Okay.
In
right?
this kind of scenario, only we use dynamic cast, right? Basically.
Yeah. So yeah, good use case for a dynamic cast when you are doing upcasting,
Okay.
right? So the thing is, if this casting is not proper or anything, this gives you a return the error, throws an exception actually.
Yeah.
Okay. Okay. So, does anyone know about designated initializer in C++?
No.
Suppose something like this. If I have to write it.
Mm,
Actually, we have used this yesterday in our code. If you would have seen properly. I don't know how to do this, but here, this is how it is done. If you see this, so this is called designated initializer, and this is available from C++20 only, not before that.
So more like
designated.
Python style kind of a thing.
So what we are trying to do here is, suppose you have a structure, right? Like suppose this is the structure,
Okay.
and how you fill the structure, you tell ki this is my, you earlier before 20, you will have to tell ki this is my first thing is this, second thing is this. But after C++20, you can tell ki, so you can actually move this after this also, no problem, right?
Before
So you
C++,
are,
before C++20, we could have used brace initializer to do this.
brace initializer is okay. That is for there. That is from C++11 only or 14. I'm not sure.
Yeah, but
Only thing I'm telling is
while
I am
initializing,
tell
we have to maintain the sequence of
maintain the
the.
order.
Yeah.
Exactly. Maintain the order. But with this designated initializer, what we can do is
Yeah.
we can
Got it.
tell ki, okay, for I am assigning this value for this particular variable,
Hmm.
right? So this way you can do designated initializer. Correct?
Yeah,
Okay.
Does this also work for objects? I
Mm.
mean classes, sorry, or just
Yeah, yeah, yeah.
structs?
Yes, yes, no, no. Classes also. Structure classes, everything. If you see here, no, if I show you the yesterday's code, we have actually used this designated initializer. Where is
Nice.
our
Yeah.
simple HTTP server WebRTC? Yeah. See here. Remember this WebSocket code that we were writing? So if you
Yeah.
see here, this is the second argument. What it is taking is some kind of, this is some structure that it is taking some variable members are there, right? So I'm designated initializer it is used. For open, you have this option. For dot message, you have this. For dot close, you have to this,
Okay.
right?
Okay.
This is designated initializer. So if you go here, and if I remove this to 7, if I even if do 17, no, this code won't compile. You check this out. It will combine only if you give 20 because that designated initializer is only available from 20.
I remember seeing this code yesterday, but I thought this code is the same chaining thing what we did in the before classes, right?
That
Where
is not
we,
chaining. So if you
I
see this
also felt
code,
the same.
yeah, that's why I thought that okay, we ये तो पता है करके.
no, 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 this is not chaining. If you see, I'm assigning values to the member variables. Where did it go? I am assigning. So this is the second argument, right? From here to here. So this is
Okay.
some structure that is taking where I'm assigning dot open, it is the value, dot message, this is the value. So it might be having some dot open, message, and close, three member variables.
Right. Right. Okay. Okay.
Right. You can check this out. If I go ahead, see, okay, let me show you. Dot dot. Go to WebRTC, CD build. So if I go ahead and build it, hopefully it is building because yesterday it was building. Yeah, it is built, right? And if I go to my CMake and if I suppose tell my CPP standard, right? So give it 17, right? And if I try to build this again, let's see. It got built. Why? CMake dot CMake dash dash build dot should not build it as available from 20 only. We're doing correct, right? This is proper. This CMake list. Check this out. I'm sure it was from CPP 720. Check this out once. So
Okay.
this actually should not work. This should start giving some error. Ki, what is this? I do not understand this. I had checked this yesterday also. It was giving error. So I changed it to 20 and it started working.
Mm-hmm.
Okay, check this once, right? I don't know why it is compiling now. Is it some cache or something it has taken? Let's see. And now it is giving some error. But anyway, 17. Okay, 17 it is compiling. Let's see 14. So maybe it is from 7 for 17. I'm not sure now. Okay, so 14 also it is not compiling. So maybe from 17. Check this one out. Okay. So okay, so last two things. One is the how many of you know about STD option?
Yeah, I
So
think it
Only
is.
learned from you.
When?
I think it.
Means you at least told about it,
STD,
right?
yeah,
Option and
STD
all those.
optional.
yeah, so it
I think
gives
it
you
like
an
allows you
option
to.
that,
Hmm.
okay, yeah, you
Hmm.
can.
Yeah, tell me. Anyone. Yeah, now both will not tell.
But you use
Yeah,
this
it
term, right, while
basically allows
explaining.
you to, like, like
Hmm.
I have encountered this in some other programming languages. So you have the option, like, some, like, for example, if the result of an operation is either something or none,
Yeah.
right?
Yeah.
So
Yeah. So you use this as a return type or as a parameter to tell ki my return type could be something or could not be. So earlier what used to happen is if something processing you happened, if something result is there, you will pass, or otherwise you will pass some null pointer or anything like that. To avoid those things, you can use something like this. So if I give you a little bit of code.
Yeah, like generally, suppose if it's not a valid index, then usually we pass
Correct.
-1, right? So
Correct.
instead of that, we can use standard optional, and we can pass standard null OPT, which basically means that you don't have a value in the answer.
Correct.
So while
So
using
see,
that,
a simple code, a divide code I'm using. So earlier, how you right? You will check b equal to 0, what will happen? Otherwise, you will throw an exception like that, something like that, right? So now I'm saying is I have a return type which is steady optional of type int, right? So either my return type will be some integer, or otherwise it could we will not be returning anything, right? So if it is 0, I'm just returning null op, right? Or otherwise this. So when how I'm doing is I'm taking in the result, and if result is there, I'm printing the result. Otherwise, I'm saying the result is not there. So this is very good thing to show in API that the moment I see this API, I know that this might not even give me something. So I need to take care of that, right? Like this, right? Simple stuff. So you'll see many code like modern CPP code using this or steady optional now. That's why I'm telling it here.
What if it's a pointer, like int star? Then
So
if we access it, then will it crash or?
there's one more API called dot value. So, like,
hmm,
suppose you're storing it in the result, so you can just say result dot
result dot
value.
value.
Or there's one more API, value or. So you can give some default value there. So like suppose if it's null,
Okay. Yeah.
then you can give some default value there and use it, that value.
Yeah, correct.
Yeah.
Okay. So also one more thing that you can see a lot of people using these days is in STD, string view. What is this? Anyone know? Sorry, string view. String underscore view. This. Does anyone know about this string view? So you use this replacing the STD strings. Why you will want to replace it is more of a something that you just want to read, something you just want to read, you don't want to do any modification. So you can use string view as a argument or even a return type. And this is said that it is much more faster because copying is not happening and all. So this gives you a better optimization than using STD string when you are not doing any modifications.
Can you repeat? Sorry.
So suppose you are passing some string and all, right? In the argument or some calling a function. So and you know in that function you are not going to change anything in that string. You are just going to read it and use it somehow.
But
Not
then
doing any
const string
modification.
ampersand.
So internally that might be doing something, but there is some copying that is happening in call string view. String view tells ki I am not doing any copying. I am just keeping some pointer there, which is of the original string. So this is something that people have seen is using a lot these days for the modern CPP. This gives you a better optimization than if you are passing a pointer or even the pass by value. This gives a better optimization. STD string
Because
view.
earlier they used to, for these kind of scenarios, to avoid to make optimize, they said the const string
Const
ampersand.
reference.
So
Yeah,
const
correct.
reference. Yeah. Also, what has happened with modern C++ is now, like, people who would have done C++ 98 and not upskilled them, it is almost impossible to decode in modern C++.
Yeah, so internally they would be doing something like this. Only thing is now instead of you doing a pointer and all operation, you do a string view and it takes care of everything for you. Right? Everything which is
internally it is still the constant contiguous memory itself at the end of the day.
Yeah, it is just a view of the original string is what it says.
Yeah.
Right. Okay. Okay. Ankita is saying I am facing one issue. So okay. So with this, I'm done with everything. So this is all from my side. I hope this should be interesting, a little opened up your mind for. So these 2-3 questions, that I have been asked in some interviews. One was in Adobe and two was in Intuit once for a CPP round of interviews. So these small
They
things
ask C++
also they can ask.
20 questions.
No, these things were not asked. The earlier one which I told you, virtual wala thing, then int is equal to object, these things were asked. Okay. You should also know a great deal about when to use which kind of casting people can ask in CPP interviews. So reinterpret cast, static cast, dynamic cast, and one
Const
more
cast.
cast is const cast. So you should know which cast is getting used where, like which is the proper cast to use in which situation, right? So this gets asked in interviews. Okay, and apart from all the general stuff, right? You need to know what does steady move does, what is perfect forwarding, these things all you should know, right? Okay.
Okay. Last thing before I will also sign off now, but when can we start interviews? Can we get some time, like 15-20 days?
So interview, I just wanted to show you one thing if you guys are here. So this is the site that you can go to. This is called desktop.com. This is all our in-house built site that we are coming up with a new product. This is still in beta and a lot of things are getting pushed every day. So you can just go and log in and so you can use it like this. So there are few things that you can use. So these are some instant meeting and schedule meeting. These are for general meeting that you can come and just use it like a Gmeet or Zoom, right? You can use these two things. And then there is a schedule interview that you can use, and you can select a topic on which kind of topic I want to schedule my interview. You can choose a date and time, right? And then you can use
C++
it.
is missing, no?
C++ is missing. That will add anyway. And then you have to enter with whom you want to interview. Like you have to know this. So you both will come. Questions will be provided by us. You will automatically receive the questions in mail and all, and you will start doing interviews, right? You'll enter the participant mail here and you'll do the schedule interview. You'll both get the mail and you, at that designated time, you can come and start interviewing each other with the question that this system has provided you, right? And if you go and record the meeting, na, if you record the meeting, I think Mithun, you have already done, no? You
Yeah,
have.
I've done one.
So if you have recorded the meeting, once that meeting is over, you can actually go. It will show you inside your recorded videos, right? And you will have an option to make it public, right? If you make it public, anyone can see your meetings that you have done. So if you see here, no, I think Mithun has already done some interviews here. So anyone can go to this desktop site and go here in feed, and you can see all the interviews that is already conducted, right? So you can learn few things from the already conducted interviews, right? So this is one thing you can do if you know who do you want to do interview with. And then if you don't know whom to interview, you can actually add your slots here like this. So if I go here, I will add title, topic, pick a date, and add one or more slots here, right? And what will happen is once you have added the slots, these slots will show up here to every other person who is there on this site. So you if you see okay, somebody has actually start doing it for suppose low level design. I don't know why 17 is showing, but suppose somebody is interested in doing low level design at 9 p.m. on 22nd October. And if you are interested with this timing and all, you can just go here and book, and then you can meet at this time and do the interview. So you can use it like this, right? So and lot of more features will come. This is also one more dashboard that we are started to build. This is for high level design that you can use. So you can create a new dashboard, and inside this you can create your high level design, like everything, like API gateway and everything that you can connect and everything. Full HLD design, you can draw it here, right? You can also go and share it with others. You can make it public, right? You can do a collaboration with, so if you enter other username or email ID and give access to the editing, you can actually edit it in real time with each other. So suppose if this particular, no, if I give it a public access, people can view it in real time. So if I copy the link and paste it here, see if you guys can access this. You might have to, might ask you for a login if you access this. Are you able to access this? Check. So it's still in the beta phase, like a lot of code is going, a lot of bug fixing is happening and all. So yeah. Can anyone access? So I can say what kind of connection I want to do. So this is for the REST API that I have done the connection, right? So full-fledged uh, HLD design we can do, right? Anyone can access?
I'm
In
not
the
able to
what
see
do I
your
need to
dashboard.
do? New whiteboard. I'm trying to do like a new whiteboard, but I'm not able to.
I'm not able to log in, Amit. What is the credential for this?
You can use your Google credential or you can use your new username and password.
Okay. I can register, you mean?
You can even go and if you do a login also, no, like this, suppose it might be showing you like this. Suppose I log out.
I think it shows internal server error if you try to access your link.
Login, if I do a sign in with Google, I'm directly signing in with Google. I'm login is successful. Like this directly you can do if you want.
Okay, let me try.
Okay.
I can
Okay.
access, but I can
I'm
only
able to access. Yeah.
You can access?
Yeah, but I can't write it. I can just.
No. So yeah, I have given the public access. In public access, you can only view. So can you see I'm moving? Is it happening for you? I'm adding new Dynamo. Suppose I DynamoDB I have added.
Yeah,
Can
I
you see
can
this
see.
on your side?
Yeah, I
Yeah,
can see.
right.
So in
How does
public access,
can you show the icon for web server? Like this is exactly what I was looking for. Like I had also messaged on Discord that I am looking for a good one where we get the right icons.
web
But
server, we'll be
web,
adding a lot more real world whatever the icons that is getting used, no? And there is one more interesting functionality we are going to add in one week or something. So everything is there. API
but you don't
gateway,
have like
cloud front.
typical web servers like boxes type.
We
Yeah,
have
you can
the general part. Go to general and just show. No?
Yeah,
So
like
it is
here you
something like
can see
backend, cache,
server.
CDN, database, front end, load balancer, pub
Okay,
search,
yeah,
server,
yeah. Perfect.
right? Correct.
So this we can use
So
for practice also?
yes, for you guys, we are making this,
Okay, perfect.
right? So
We will
right now
have
Hmm,
we will also have a store where you can come and clone the designs and you can work
yeah,
on
I'll
top of
show
them
that.
as well. Yeah.
So if you go
Perfect.
here, no, so there is something called DAX store, right? We have named it. So whoever has made the any design and made it public, remember I made it public, it will show you all here. So you can actually go and open it, which will be in view mode. But if you want to use the same design, you can actually clone that design and then start doing your own. You can
Okay.
start editing it. So this will have better UI designs when we also design and put it in the public. You can come here and see all the designs that are there. So who is the creator who has given this design? So if you go and create and make it public, it will actually show here. I can see your design, what you have done, right?
And can we give our personalized account to means view of the account to future employers or employers to see that these are our designs?
You can. So suppose if you can go here in the setting, collaboration, and you can add that particular username and give them kind of access also. Is it
Okay,
edit access you want to give or just the view access you want to give? You can give it here and share this
perfect.
particular URL, right? So
Yeah.
that is also there. Only thing is in public access, we don't want to give the edit access because suppose 100 people are viewing it, 100 people are editing, that is not a good use case, right?
Okay.
You
Right.
want to give the editing access to one, two people, three, right? That you can give it from here, correct? Okay, so please go ahead and go and do whatever you schedule the interviews and all if you want and check out this dashboard and a lot of things will be keep coming because this is still under a lot of development that is still going on, so it would be good if you can give us good suggestion and feedback. That will be very much appreciated.
Amit, I just give a suggestion in the form only as a small minor business idea. I don't know how good it is, but regarding my experience only, like you guys, because you have this platform, you can give this certification, certified interviewees, means who knows how to take interview. Because there are small
Okay,
small things here, like how much time to give to think, how much to pause, how to do
correct.
interviews. Because sometimes people overload you with lot of questions, and when you are thinking, still people ask you something more or add something more on top of it. So that right
Mhm.
combination should also be a certified thing, I believe. So tomorrow, if this becomes a good concept, then
Mm.
there will be specialized interviewers who have gone through this educourses platform and taken the certification, who knows the tricks of the interview. And I thought you are
Yeah,
the
yeah.
best because you are into this business.
Yes, that is a very good point. Like, yeah, we'll take it up. That is very good. So suppose any profile is on the profile, it will be some tick or something will be mentioned. He's a certified interviewer for particular topic also, like in front end or in back end or data structure
Exactly,
algorithm,
exactly,
like
yeah,
that.
that
So
also.
people would want to schedule interviews with you, and that we can give some kind of like commercial benefits also for those
Right.
people, right?
Yeah, and they would have done
Mm,
interviews
mm,
for DSA or something with you, maybe 8 10 interviews,
mm,
maybe you should have those
mm,
things. And yeah.
mm,
S- so I thought it was a good idea, like especially with this platform.
correct, no, correct, true. We'll take up this very good suggestion. Thank you. Yeah,
No
so
problem.
Sorry,
this is it
uh,
from my side.
sorry.
Yeah.
One sec.
Mm.
Sorry, I just wanted to let everyone know that your certificates for the course will also be available today. Like we'll make it available on the site itself. Sorry.
Nice.
Okay.
Okay. Uh, okay. Ankita was asking something. I'm facing issue with SS server. Do you want to do it?
Yes.
Yeah,
Well,
share the screen.
yeah.
I'm stopping my share.
Okay.
Yeah.
Uh, can you see my screen?
Yeah, I can see your screen.
Yeah. So actually, while I was running, so when I'm giving the username, actually, so in server, like over in here, it is sending from the client. But in server, it is like not receiving. Like
Okay.
it's not coming in the server.
So you are writing simple TCP server right now.
No, this is yeah, TCP server client, but this is like for SSH I am doing actually.
Acha, okay. Okay.
SSH homework you have
So
given.
there is no data that is getting received on the server side, is what you are saying,
Yeah,
right?
yes.
Okay.
So
And your server is running on Linux,
Linux.
AWS.
Linux. I have made it like extensible, like it can be support in all the platform.
Mhm.
So like that I made. I have
So
written for Windows till now.
can you? So it is only TCP, no? It is not HTTP, right? So what you can
Ah,
do here is, where is your client? Your client is on Windows machine. Where it is?
no, all are in right now. I'm running in Linux machine actually.
Okay, so your client is also on the same machine, right?
Yes.
Okay, so it's not the problem of some security issues and all. Means security inbound outbound rules. That is what I wanted to check.
Yeah.
Okay. So the
So,
first thing is the very first thing is server IP that you need to change. Instead of 127.0.0.1, first make change it to 0.0.0 because this is for the local host. If you try to get the data from anywhere outside, it will not support. So that is first thing.
okay.
0.0.0, not 1, 0.0. Okay. And where you are sending the data, show me.
So this is the main. One second. Just disconnected.
Other also you can see if you can help it out.
Sorry. This AW is connected.
Disconnected, I think.
Um, Once I'll close and I'll open again.
Yep. Some problem with your remote.
If this AWS server sometimes
Yeah, it happens. It happens.
it doesn't connect.
Yeah.
Okay, right. So, uh,
But no problem. You might try once. Once it maybe we can, if you want, we can sit if we still get a problem. Or other people also, if Rama and all has already done this, so if she can also help you. If you guys can
okay.
also group together and check it out, your each other code. Or you can put it on the GitHub
This,
and share the link. I'll check the code.
okay.
You that also you can do.
I will share. Actually, I thought of sharing in the Discord first. Then I thought ki let I will ask in the class. But
That's fine. But you put the code on the GitHub, share the link. I might check the code. Yeah. Okay.
yeah, okay.
Okay. Okay. So everyone, thank you so much for being there, like for all the 6 weeks. Okay. So any help you need or anything, just ping on the Discord group. That is always open. So I'm not going anywhere. So thank you. Signing off. at least for this cohort. Hope to see you all again, maybe some other time in some other cohort. So thank you, everyone. Bye-bye.
Hi, Amit. Bye.
Bye.
Thank you. Bye.
Yeah. Yeah. Thank you, everyone.
Thank
Thank
you.
you.
Thank you.
Thank you.